Okay, so this is the graphs of equations homework. So the first thing we're doing is we're just generating a table of numbers to plot to get points that we can then plot on a graph. So in this case, we have this table of data points, and we have the function, which is y equals 5 minus x squared. And we have the x variable, which is the independent variable. We have the y variable, which we also call f of x. So y is the ordinate, the y coordinate, but that's also the value of the function. And then we have x comma y, which is the ordered pair. Now, it's always a little tricky to figure out what numbers to use here. Now, because this is symmetric around the y-axis, then it makes most sense to have these numbers symmetric around the y-axis. But it's, like I said, it's not always obvious which numbers to put in here. So all we have to do is evaluate the function at these values of x. So to do that, you just plug x value into the equation. So you substitute for x. So you'll have negative 2 squared. Let's just write them all out so you can see how it goes. F of negative 1 is 5 minus 1 squared, and f of 0 is 5 minus 0 squared. F of 1 is 5 minus 1 squared, and f of 2 is 5 minus 2 squared. And the reason it's symmetric around the y-axis is because we have these squared terms, and when you square something, a negative number becomes positive and a positive number stays so they should be equal to each other. So here you get 5 minus negative 2 squared, which is 4. So you get 1. Here we get 5 minus 1, which is 5 minus 1, which is 4. Here we get 5. Here we're going to get 4, and here we'll get 1. 5 minus positive 4. Okay, so those are the data points. So the y values are going to be equal to 1, 4, 5, 4, 1. And the coordinate pairs are just the x value and then the y value. And those are the points that we're going to plot on the graph. And that's the whole idea of a graph, is to kind of summarize this. These are just 5 specific points, but what a graph does is it gives you a way of kind of looking at what they are for a larger number of values. Now you're not going to be able to get the exact value off of the graph, but you can have some idea of what it looks like. So our points are, so this is our x-axis, this is our y-axis, and we'll use, you want to choose a scale that maximizes the space on the graph. So you can see the maximum y value is 5 and the minimum is 1. So you might say, well, let's go from 1 to 5, but we do want to have a little room to kind of extrapolate. So what I would do is I'm going to go up to plus 5 here and minus 5 there. So you have those equal to each other, so the middle is 0. And in this case, we could go from negative 5 to positive 5, and then these little squares would be 1 by 1 or equal length, or you could go from, say, 0 to negative 3 and 0 to positive 3. So I'm going to go from negative 5 to positive 5. So we've got negative 2. So you might go 1, 2, but the reality is that every 2 grid marks is 1 unit. So sometimes you want to put these we call them tick marks, and we could put in 1, negative 1, negative 2, negative 3, 4, 1, 2, 3, 4. These are the axis labels, and then you can do the same thing in the y direction. So we're going to start at -5. Here's 0, 0, and there's 1, 2, 3, 4. Okay, so now we can plot some things. -2, which is here, and 1, just right there. Then we have -1, 4, that's right there. 0, 5, 1, 4, -2, 1. And so what we can do is, kind of estimate what's going on here. So we're, this is a hand-drawn graph and giving it kind of the approximate shape. And then in the old days, you used to use what were called French curves to kind of estimate what it might look like. If we wanted it to be more accurate, we could evaluate the function at -3 and +3. And then we would get another point. Of course, the more points you get, the more work it is. So you want to do as little work as possible to get a good idea of what's going on. Okay, you should have seen that before, so I'm not going to belabor that at this point. The next group of problems are finding x and y intercepts. So these are all different kinds of equations: linear equations, root equations, absolute value equations. So in all cases, if you want to find the x-intercept, which is across this line, so the x-intercept, or the x-axis, is when y equals 0. And the y-intercept is when x equals 0. So the y-intercept is where this curve crosses the y-axis. But the y-axis is the line x equals 0. So all you have to do is plug in here y equals 0, and then figure out the values of x. So if you add 6 to both sides, you'll get that. Divide both sides by 6, you'll get 6/5. And do the same thing over here, except you set x equal to 0, so you get y equals 5 times 0 minus 6, or y equals -6. And the actual x-intercept is going to be a ordered pair, which is going to be 6/5, which is the x value, and 0, which is the y value. And here you're going to have x, which is 0, which is the x value, and -6, which is the y value. And you could plot these 2 points and then draw a line between them, and then you could draw the line. So that's what happens when you have linear equations. Pretty simple. You end up with a linear equation, well, an equation in one variable. You just solve for it. You've been doing that since Algebra 1. Okay, now for the second kind of problem, we have a square root. So you can still do the same thing. The x-intercept is when y equals 0. So let's do that first so we have enough space. So you set y equal to 0. So the question is, what value of x on the right-hand side gives you 0 on the left-hand side? Well, you might just say, well, all I have to do is take the square root of 0 and I'll get 0. That's one way to think of it. So you could, the square root of 0 is 0. So you could just say x plus 4 equals 0, x equals -4. Or you could square both sides. So you'd have 0 squared equals the square root of x plus 4 squared, which is 0 equals x plus 4, which you get x equals -4. Okay. So our coordinate pair is going to be -4, 0. And then for the y-intercept, you set x equal to 0. So we get, to do that, you just say y equals the square root of 0 plus 4, which is the square root of 4, which is 2. And therefore the y-intercept is going to be 0, 2. Now we haven't talked about the shape of these curves at this point. We're not plotting them and looking for the x and y intercepts. We're just using this general procedure. Okay, so number 4 is y equals the absolute value of x minus 7. So, x-intercept, that's when you set y equal to 0. So you'd say 0 equals the absolute value of 2x minus 7. And in this case, what the absolute value function is, it's saying that make sure I get this right here. Because, if you think about the absolute value function, it could look like that. It could look like that, or it could go below. So you can have 0 x-intercepts, or you could have 1 x-intercept or 2 x-intercepts. So the question is, is there more than one value of x that would make this go to 0? And the answer is no. Okay. So what you do is you'd say 0 equals the absolute value of 2 times 0 minus 7. But the absolute value of 0, there's no plus or minus to it. So, and actually we can't have this one, thinking about it. Because, or this one here, yeah. Because those would require something to be outside of the absolute value sign. So these are all going to be like that. There's only going to be one x-intercept. If you had plus 3 or something like that, or minus 3, then you could end up with more than one intercept, or with but for this case, this absolute value function, it's only one situation. So so what you get is 0 equals 2 times, and why did I put that equal to 0? That's wrong. Okay, so you get 2 times x. So 2x minus 7 equals 0, 2x equals 7, x equals 2 sevenths. Okay, so that is where, if I plug 2 sevenths in here, I'll get 2 times 2. Did I do that right? I got the other way around. Sorry. You're like, why don't you fix these things? Well, it just shows you where people can make mistakes. So the kind of mistakes. I make mistakes sometimes. Okay, so if you plugged in x 7/2, you'd get 7 here, minus 7 would be 0. So again, the coordinates are going to be equal to 7/2 comma 0. So this thing is shifted to the right 7/2 of a unit. And then as far as the y-intercept, there you set x equal to 0. So that means you get y is equal to the absolute value of 2 times 0 minus 7, which is the absolute value of negative 7, which is 7. So let's plot this thing, because absolute values sometimes we're not quite as familiar with about what's going on. So what you'd have is you'd have the x-intercept, it's 7/2. So let's go from negative 10 to positive 10. So 7/2 would be 3.5. 1, 2, 3, 3.5. So that's my x-intercept. And then the y-intercept was 7. 1, 2, 3, 4, 5, 6, 7. And because of symmetry with the absolute value function, it's going to be symmetric around this point here. So we went 1, 2, 3.5. So we go 1, 2, 3.5. So that's another point. We're using symmetry there. So it's going to look something like this from that direction and that direction. We'll talk about more about these later. Okay, number 5, y equals 2x cubed minus 4x squared. So again, the x-intercept is when y equals 0. So you set the left-hand side equal to 0. And in this case, you would use some kind of factoring because we have a third-order equation. Now, you can if you have a common factor, you can factor it out, and you can see that I can factor out 2x squared, and 2x, this divided by 2x squared is x, and this divided by 2x squared is minus 2. So what we have is that y equals 0 when x equals 0 and when x equals 2. So this part gives you the x equals 0 part, and this one gives you the x minus 2 equals 0. So there's two y-intercepts. And then to find the y-intercept, that's always the easier one. Set x equal to 0. So you get y is equal to 2 times 0 cubed minus 4 times 0 squared, which is 0. Let's go back here. So the coordinates are 2, 0, and 0, 0. Y equals 0, so it's both these have y equals 0. There's two cases of x. Over here you have 0, 0. So this is both a y and x intercept. Okay, so that's how those kinds of problems work. Next question is about symmetry. So the next three problems about symmetry. So you have x squared minus x equals 0. So there's three kinds of symmetry. There's x-axis, there's y-axis, and there's origin. And if you look in your book, there's tests for that. And let's just look at it. So it says the graph is symmetric with respect to the x-axis if when x and y on the graph is the same as x comma minus y. And just because I know this is a quadratic equation, it's going to be symmetric around the y-axis. So let's just prove that. So if what you do is you see whether, in this case, substituting, this is xy. Now if you substitute in minus x comma y into this equation, you'll have, for x, you'll put in minus x. And you see that negative x squared is x squared. So let me move this down. So quantity negative x squared is just x squared because the negatives can't, negative times the negative is a positive. Here we still just have negative y, and you see these are the same. So because those are the same, it's y-axis symmetry. Now the second one is y equals x cubed. So we have an odd power. So that's usually either the odd power can mean it's x-axis symmetry or it's origin symmetry. Again, I know from experience this is symmetric around the origin, and what it says there is that if I substitute, if I put a negative x and negative y into this equation, so f of negative x, well, it's not really f of negative x, negative y, it's just substituting in those in for x and y. So for y I'll put in negative y, and for x I'll put in negative x. So what happens is negative x quantity cubed is negative times negative times negative is a negative. So I get negative x cubed. So I have negative y equals negative x cubed. Divide by negative 1, you get y equals x cubed. Okay, so these are the same. So because this is the same, then it's origin. Now the question is, what is, when do you have y-axis symmetry? Well, usually it's not a function if it's y-axis symmetric. So, but I'm not sure if the next one example is a y-axis or an x-axis. Let's just give, this is not one of the problems, but if you had y squared equals x, or y equals plus or minus the square root of x, what that function looks like is like this. It's like a quadratic equation but flipped over, and so in that case you can see it's symmetric around the x-axis. So and you can see that if for x-axis symmetry, what it says is that xy, which is the original equation, is the same as x negative y. So if I plug in, for x I plug in x, and for y I put in negative y, what you'll see is that, again, when you square this, the negative times the negative becomes positive. And so, because these two are the same again, that means it's x-axis symmetric. Okay. The last example that we have is y equals x over x squared plus 1. So this one, is not as obvious what it is. So let's apply all these different ways. So we've got x-axis that says xy is the same as x negative y. So let's try that. So what we'll do is for y we put in negative y. For x we put in x. Well, if I multiply by negative 1, I get this. Okay. So these are not, this and that are not the same. Not the same. So that's not going to work. Let's try y-axis. So what you do there is you compare xy versus negative x comma y. So what we get is, so for into this original equation, for y we put in y. For negative x, for x we put in negative x. You get negative x over negative x squared plus 1, which is negative x over x squared plus 1. So we square negative x, you get positive x squared. Okay, not the same. Okay, so because this is not the same as that, then it's not y-axis. Okay, let's try origin. So that says compare xy versus negative x, negative y. So we have, for y we put in negative y. For x we put in negative x. So that gives you negative x over x squared plus 1. Multiply both sides by negative 1, you get y equals x over x squared plus 1. So that is, they are the same. So in this case, it is symmetric around the origin. And to prove that, we're going to plot it. So if we plot y equals x divided by x squared plus 1, you see right there. And so you can see how it's something here in the first quadrant goes to the third quadrant. And there you can see the symmetry associated with it. So that makes sense. Everything looks good. So that's what we have for graphs of equations. You need to be able to plot, plug numbers into a function equation, find the x and y values, plot those, and estimate the shape. The next is to find the x and y intercepts of equations. And the third case is to look for symmetry, test for symmetry around either the x-axis, y-axis, or origin. Okay, so the last three problems. So problem number 9. Again, we're doing some more x and y intercepts. I've added these problems in because they're the ones that you'll most likely see on the test from this section. Okay, so problem number 9. So the same thing applies. To find the y-intercept, we set x equal to 0. So if we do that, we'll get y equals 0, square root of 0 plus 4 minus 3. And the square root of 4 is 2, so you get 2 minus 3, which is negative 1. So the y-intercept has an x value of 0 and a y value of negative 1. Now to find the x-intercept, we set y equal to 0 and solve for x. So we need to solve for x, we need to get rid of the square root. So what we're going to do is we're going to take the negative 3, move it to the left-hand side. And then we'll square both sides. So 3 squared is 9. The square root of x plus 4 squared is x plus 4. And if we subtract 4 from both sides, we'll get x is equal to 5. And if we were to sketch this function, it would look something like this. It would have a y-intercept of negative 1 and an x-intercept of 5. And the beginning, if you set x equal to 0, you'll get, actually, no, that's not right. So the most negative x value that this thing can take on is negative 4, because you'd have negative 4 plus 4 give you 0. Anything larger or more negative than negative 4 would give you a negative square root of a negative number. So it's, you'd have actually start to here, you'd have negative 4, here you'd have 5, and the y value here would be negative 3. So let's do that. So you'd have, when x equals negative 4, this goes to 0, you get y equals negative 3, so that's that point. When x is equal to 0, you get y equals negative 1, and when y equals 0, you get x equals 5. And the function looks something like that. Oh, problem number 10, similar kind of thing. So you get y equals the square root of x minus 2 plus 3. Again, to find the y-intercept, you set x equal to 0. And then solve for y. So if I do that, I'll get y equals 0 minus 2 plus 3, which is y is equal to the square root of negative 2 plus 3. Well, we can't do that. You can't take the square root of a negative number. So this means that the y-intercept does not exist. What's happening is the function is starting to the right of the y-axis, so there's no, and it moves from left to right, so there's no way that it can intercept. Okay, so there is no y-intercept. So anytime that you put 0 in for x, basically anytime you subtract a number here, x minus any number is not going to have a y-intercept. Okay, to find the x-intercept, you set y equal to 0. Okay. So what do? We take this to the left-hand side. So you get negative 3 equals the square root of x minus 2. And actually, I think I had, is that right? Yeah, it's plus 3. Okay. Now the question is, what the heck you do here? Well, you square this, but the problem is when you get to this point, it's a little subtle, but the square root, there's no number whose square root equals a negative number, so you could square this and you'd get the wrong answer. Okay. So if I square both sides, negative 1 squared is positive. Negative 3 squared is positive 9. And you solve for x, you get x equals 11, but that doesn't work. And that's because here there is no case, no value of x that's going to give you a negative number here. The square root of a number either is greater than 0 or it does not exist. So this one also does not exist. So anytime you get to a point where when you're solving for x to find the y-intercept, to find the x-intercept, when you set y equal to 0 and solve for x, you're finding the x-intercept. Anytime you get a negative number here. So this, anytime this number is positive, then there are no x-intercepts. So that's a little sneaky, tricky. If I gave that kind of problem to you, it'd still be possible. And the final one is one of these quadratic equations. And a quadratic equation, you can get 0 x-intercepts, you can get 1 x-intercept, you can get 2 x-intercepts. So how does that happen? Well, if you can't factor this equation, if there are no solutions to this, then you're not going to have any x-intercepts. If this gives you a perfect square, then there's only going to be 1 x-intercept. But if you can factor this, then you can get 2 x-intercepts. So which one were we doing first here? We were doing the y-intercept first, so let's do that. So again, any relationship, I'm not going to say function, but any equation to find the x and y-intercepts, you go through this procedure. So we set x equal to 0 to find the y-intercept. Well, both these terms are going to go to 0. 0 squared and negative 6 times 0, so you just end up with the constant term. So that's always easy for a quadratic equation. So the y-intercept is going to be equal to x equals 0, y equals 8. I guess I should go back to these other problems that we did that one correctly, but let's go down here. So the actual x-intercept here is x equals 5, y equals 0 as a coordinate pair. So I've got a coordinate pair here. Now to find the x-intercepts, you set y equal to 0. And like I said, there are 3 possibilities. There's 2 solutions, 1 solution, or 0 solutions. I'll give you 2 more examples after this. So in this case, you can factor it. So this is assuming you know how to factor, which you should. And so you can factor that. So what 2 numbers multiplied together give 8, and added together give -6. Well, the answer is -2 and -4. Multiplied together give 8. Added together gives -6. And the answer is not -2 and -4. To have the product be 0, either this has to be 0 or this has to be 0. If you have if you have a product of 2 numbers, one has to be 0 or the other has to be 0. Theoretically, they could both be 0. So we set this factor equal to 0, solve for x, so we get x equals 2 here and x equals 4 there. So those are our 2 x-intercepts, and we can represent that as a coordinate pair. So it's going to be 2, 0 and 4, 0. So that's the problem. Now let's just give you 2 examples here of cases where you get 1 x. We're just going to look at the x-intercepts. So if you have y equals x squared minus 6x plus 9, you can factor that, set it equals 0. So you'll get x minus 3 times x minus 3. If you factor these 2 multiplied together give 9, these 2 added together give -6. And so they're the same. So you get x minus 3 equals 0, or x equals 3. So there's 1 x-intercept, 3, 0. It's a repeating one. And what that means is that the function is going to look something like this. It just touches the x-axis. It doesn't actually cross the x-axis. So that's case of 1. And then if we do something like let's do this. I think this will work out. Usually if you have positive numbers, this is where you get 0. So, you know, just looking at it, well, let's do something that actually works out and factors easily. So let's say we had well, actually, it can't factor easily because it doesn't factor. That's the point. Okay, so you look at that and you say, I don't know how to do it. I don't see a factor. So how would I guarantee that I don't have a factor? Well, we did talk about completing the square, and what would happen is if I take this part, well, actually you have to go a little further here, but say it's plus 10. Okay, so we're going to complete the square. So we're going to take the plus 10 over here. We're going to take half of 4. So we divide by 2. We square it. 4 divided by 2 is 2. 2 squared is 4. So we add a 4 here. We subtract 4 there. And this can be made into a complete square. So we take this number here, 2. X plus 2 squared. You see if I multiply x plus 2 times x plus 2, I'll get x squared plus 4x plus 4. Here I get 10 minus 4, which is 6. And when I go to the next step, I'll get a -6 over here, like that. Now this is where we could just stop. Because just like in these other problems, you know, we can't take the square root of a negative number. So anytime you get to this point in completing the square, you can say there are no solutions. Because there are no solutions, there are no x-intercepts. So that's the case of 0 x-intercepts.